In this video, we're going to look at the graph of the secant function. So we'll be looking at y equals the secant of x. And just like before, I'm not going to spend as much time with this video as we did with the cosecant because you're going to find it's very similar to graphing the cosecant function, except for now we're looking at the secant, which will be the reciprocal for 1 over our cosine. Okay, so if we go and graph our secant function, going to the calculator, once again, we don't have a secant button, so we'll have to use 1 over cosine. So we take 1 divided by the cosine of x, and again, we will go to zoom trig, and once again, make sure that your calculator is in radian mode. So if I go to zoom 7, that's zoom trig, and here we will have the graph of our cosecant. Or I'm sorry, the graph of our secant rather. And if we look here, this is the graph of our secant function. And once again, notice here we're going from 0 to 2 pi. And here we would have pi over 2, pi, and 3 pi over 2. And what we're going to notice here, kind of similar to the graph of our cosecant, our secant function, notice the graph is splitting here at pi over 2, 3 pi over 2, and then of course over here on the negative side as well. So once again, we're ending up with these vertical asymptotes, pi over 2, 3 pi over 2, and again, it's the whole relationship of looking at our unit circle as we go around. We have our coordinates 1, 0, 0, 1, negative 1, 0, and then at the bottom we have 0, negative 1. So if we look at plotting points here as we go around for the graph of secant, if we have y equals secant x, then we're really looking at 1 over the cosine. And what's going to happen at pi over 2? So if we look at 1 over the cosine of pi over 2, well, pi over 2 is here at the top of the circle, and the cosine's looking at the x-coordinate, so therefore we get 1 over 0, and again, the division by 0 is undefined. So therefore, at pi over 2 and 3 pi over 2, notice that we have an x value of 0, which makes the secant function undefined. And you will notice if we go back to the calculator, and if I go down here and I look at simply the graph of our cosine function, you're going to see kind of the similar thing happen with our sine function we had before. Notice how the peaks and valleys will come down and touch the graph. So again, if we kind of compare this with our secant function, so if we have y equals, let's see, what do we want to use here? I'll use, this is our secant. So we get this part of the graph here, here, and here. And if we're looking at the graph of simply cosine x, that's giving us this part of the graph. So once again, we'll notice from 0 to here to 2 pi, we're still getting one full period. So just like before, if we were to go from this point here on the secant, then this point here, the graph then would start to repeat itself because it would then continue up this direction to give us kind of this U shape. So therefore, the period, just like before with the cosecant function, here with the secant, it's still going to be 2 pi. So not to spend too much more time with this, hopefully you can see then kind of the relationship of how this is related to the cosine So again, if you know the graph of cosine, then we can certainly look at the graph of your secant, because then again we're going to end up with kind of these u's or upside down u's or n's here for the graph where it touches. And again, one thing to make note for the cosine function at kind of these peaks and valleys of your cosine function is where the tip of the secant function is going to stop. And then of course we will have our vertical asymptotes at any point that touches here for the cosine function. Wherever the cosine function is equal to 0, again going back to the unit circle, that's going to happen at your pi over 2 and 3 pi over 2. We're going to end up with your vertical asymptotes. So hopefully now you're familiar with the graph of the secant function. So again, in order to use the calculator, we have to enter this as 1 over the cosine of x.